The Origin of Life by Anthony Basilone, Michael Colarusso, and Sarah Laval. When did life originate on Earth? Scientists presume that life has existed on Earth since the moment the environment of Earth was stable enough to support life. These scientists can approximate the time when life appeared on Earth through evidence from prehistoric organisms. The earliest, nearly definite evidence comes from stromatolites, a type of cyanobacteria found in Greenland, which date back 3.7 billion years. But scientists presume life began earlier because of how complex these bacteria are. Zircon rocks found in Western Australia contain high levels of carbon in a form that is commonly used in biological processes, and they date back 4.1 billion years. Theories. The question that is even more widely debated is how life came about on Earth. Early scientific theories included the idea that life was brought to Earth from a distant world, and the first living organisms arrived on a comet or asteroid that struck the Earth. These theories, while not entirely disproven, are widely accepted as untrue. This special creation theory involves religious ideas and usually includes a higher power who created all living organisms at once as they exist today. Abiogenesis, or spontaneous generation, is the theory that living organisms generated spontaneously from inanimate objects. Examples of this include insects forming from dew and maggots forming from meat. This theory was later disproved by Francesco Redi. Theory of biochemical evolution. This theory states that life initially arose from a collection of chemical substances by a progressive series of chemical reactions. Solar radiation and lightning are theorized to be the main sources of energy for these reactions. Organic compounds accumulated in oceans and formed a hot dilute/primordial soup. Proteinoids and nucleoproteins aggregated and precipitated in oceans and formed colloid aggregates called coacervates. Coacervates were able to absorb and assimilate organic compounds from the environment, which resembles metabolism, and budded to divide. These coacervates are theorized to have formed into primitive cells.
Theory of deep-sea hydrothermal vents. Recently, some scientists have presented the theory that life originated near deep-sea hydrothermal vents. Black Sea hydrothermal vents were the first of these vents to be discovered, and were extremely hot and did not allow for chemical evolution. These hydrothermal vents spew key hydrogen-rich molecules, and the rocky nooks in the vents could have concentrated these molecules together and provided mineral catalysts for reactions. These vents are rich in chemical and thermal energy and can sustain ecosystems. Oxygen in the atmosphere of early Earth. Cyanobacteria were the first organisms to undergo photosynthesis, which released oxygen and caused a sudden exponential increase in the amount of atmospheric oxygen. Later, though, these cyanobacteria drifted further down into the ocean and died, which decreased oxygen levels as they decomposed. This meant that the ocean was still not suitable for organisms that require oxygen to survive. The beginning of multicellular life. Microbes, single cells with no organelles or nuclei, began to change and develop into more complex organisms after being initially anaerobic heterotrophs in the oceans. Microbes began to live inside other microbes and act as organelles for them. This led to the formation of mitochondria and nuclei, and eventually into eukaryotic cells. As these more complex cells began to group together, they developed into more complex organisms, and each group of cells formed sections with specialized functions. First animal life on Earth. The clusters of cells, which all had specialized functions, formed into the first animals about 800 million years ago. These animals included sponges, which need oxygen, but not nearly as much as any other animal do, so they were able to tolerate Earth's atmosphere. Sponges later developed and evolved to have more diverse and complex body structures, which gave way to more groups of animals. Sea sponges were most likely the first animals on Earth.
Alright, so moving on to the Ediacaran Period. During the Ediacaran Period, which was 580 million years ago, a great amount of other seafloor organisms existed along with sponges, and evidence for the existence of these organisms exists in fossils of sedimentary rocks. These organisms do not resemble the body structures of modern living organisms, though. Toward the end of this period, oxygen levels rose to a point that could sustain oxygen. At the bottom of the slide, you can take a look at two pictures that depict organisms from the Ediacaran period. Okay, so I know what you're thinking. How did Ediacaran life go extinct? Well, Close to 501 million years ago, most of the organisms that existed during the Ediacaran period disappeared, which was due to a major change in the environment. Worm-like creatures began to excavate the ocean floors, which may have disrupted the favorable conditions of some Ediacaran organisms and improved conditions for other animals, which probably caused a shift in the prevalent life forms at the time. Ediacaran worms, such as those depicted below, could have caused major environmental changes that led to the extinction of Ediacaran organisms.
The Cambrian Explosion. The Cambrian Explosion refers to the period 541 million to 485 million years ago, which saw the development of many new life forms on Earth. Shells and spines developed as hard and protective body structures. Burrowing became a common action among animals. Heads and tails became prevalent, and animals became more active. Okay, moving on. Diversification occurred because of the development of various feeding styles, and many of the Cambrian organisms eventually went extinct. The development of such a vast amount of new life forms led to a significant change in Earth's environment, and the types of animals that existed by the end of the Cambrian period still exist today, and they gave rise to food webs and organisms that would eventually evolve into modern organisms.